Hello students, welcome back to KHC Online Education. Before we start with today's lesson, I would like you to solve these questions and here are your answers as well. We are going to start with cube roots of perfect cubes. So before we start, we should know what is a cube number, what are perfect cubes and what is a cube root. Okay, so what is a cube number? Numbers numbers obtained when a number is multiplied by itself three times are known as cube numbers. So whenever you multiply a number with itself for three times, when you multiply it for three times, the value you get is known as the cube of that number. Okay, so 8 is known as the cube of 2. In short, we write it in the powers 2 to the power 3, or which is actually read as 2 cube. So similarly, the cube of 3 is 3 cube, or which is 3 times 3 times 3. The value is 27. So 27 is the cube of 3. 8 is the cube of 2. Okay. So these are cube numbers. What are perfect cubes? If in the prime factorization of any number, each factor appears 3 times, then the number is a perfect cube. Now I'm sure you know what is prime factorization. Okay, if you don't know, then you can quickly see how is it done. For example, if I want to prime factorize 8, okay, I'll start with the smallest prime number, that is 2, which divides 8, so I'm going to use 2. 2 times 4 is 8, 2 times 2 is 4, and 2 times 1 is 2. So this is done. Now 8, for 8 I see what are the prime factors. It's just 2 to the power 3, okay, or 2 cube. So now, since I could express this 8 in the I could express this 8 and the factor of 8 2 appears 3 times while prime factorizing the number 8. 8 is known as the perfect cube. So what are perfect cubes? Perfect cubes are those particular value that you get, or for those particular numbers you have the prime factors and that factors appear 3 times exactly. Such numbers are known as perfect cubes. So that is why 8 is a perfect cube. But if you try the same thing for 18, you see the first prime factor of 18 is 2. 2 times 9 is 18. Now 9 is not divisible by 2, so you use 3. 3 times 3 is 9, 3 times 1 is 3. So you see that for 18, there are two factors, 2 and 3. The power of 3 is 2, or basically 3, it appears twice. So I write 3 square and 2. So I see that the factors could not be appeared 3 times, or the factors did not appear 3 times. That is why 18 is not a perfect cube. Okay. So here is a small note. Cube of even numbers are always even. So if you multiply an even number 3 times with itself, the answer is always even. Similarly, if you multiply an odd number with itself for 3 times, the answer is always odd. The cube of a negative number is always negative. If you multiply a negative number with itself for 3 times, the answer that you get, or the cube value, is also negative. Now, finally comes the cube roots. The cube root of a number is the special value that, when used in a multiplication 3 times, gives that number. Means, so cube root is that number, or is that particular unique value, okay? When you use that particular number 3 times, and if you get the answer that, if you get the answer, so that number which is being multiplied 3 times, that number is known as the cube root. Okay, for example, 8, 8 is the cube of 3. Sorry, 8 is the cube of 2. Then 2 is known as the cube root of 8, because it's 2 that you have multiplied with itself for 3 times, and because of which you got 8, right? So 8 is known as the cube of 2, whereas 2 is known as the cube root of 8. So cube and cube root are nothing, they are just the reciprocal procedure, okay? So they are just the reciprocal. Cube root is the reciprocal procedure of calculating a cube. 27 is the cube of 3, whereas 3 is the cube root of 27. So 3 is that particular number which is being multiplied 3 times to obtain 27. So 3 is known as the cube root. So if 2 is the cube, okay, if the cube of 2 is 8, then the cube root of 8 is 2. Okay, so that is the relation between cube and cube root. Now to find out the cube roots of perfect cube numbers, it is very important for you to remember this table. This table is the table based on the first 10 numbers and their cube values. Okay, so you see the cube of 1 is 1, cube of 2 is 8, cube of 3 is 27, and so on. So it is very important to memorize this list before proceeding ahead. That's an important note. Now we are going to draw our attention to the underlined numbers in the box. So you can see in the box the numbers, okay, the last digit or the units digit has been underlined in both the numbers, okay, for the given number and the cube number as well. You see that the units digit has been underlined. So you will be able to figure out some unique characters about these units digits. Okay, let us see what are these relationship. First relationship that you see is cubes of the numbers ending with 0, 1, 4, 5, and 6. Look at this. Numbers ending with 0, 1, 4, 5, 6, and 9. Look at their cube numbers. Even their cube numbers are ending with the same digits, are they? Similarly, cube of the numbers ending in 2 ends with 8, and cube of the numbers ending in 8 ends with 2. So 2 is exchanged with 8, right? So 2, when you cube a number ending with 2, the cube value will end with 8. And if you cube a number ending with 8, then the cube value will end with 2. So 2 and 8, they have exchanged their units digit while calculating the cube value, okay? Similarly, cube of the numbers ending in 3 ends in 7, and cube of the number ending in 7 ends in 3. So even like 2 and 8, 3 and 7 also exchange their units digit, okay? So these are the three properties that you see regarding the units digit of a number and its respective cube value. From the table, we can conclude that all cube roots, so basically the number those are given out here, they are nothing but cube roots only, right? So for example, 4 is the cube root of 64, isn't it? So now you see that the last digit of the cube and last digit of the cube root has the same relationship. 1 ends with 1, 2 ends with 8, 3 ends with 7, 8 ends with 2, 7 ends with 3. The remaining, they remain same, right? They are all same. Even this was same, okay? So in case of 2, 3, 7, and 8, the odd number exchanges with the odd number, so and the even exchanges with the even number out here. So that is the main property that you need to remember for solving out the cube roots of perfect cubes. While solving, you need to keep one thing in mind, that is to put a slash before the last three digit. For example, if you are given this number 103823, then you put a slash before the last three digits. Similarly, whatever the number of digits you have doesn't matter, but you put a slash always before the last three digits, okay? So we will solve the cube root in two parts. First, we solve the right hand part or the last digit, okay, units digit, and then we come to the left hand part of the answer. So let us find out the cube root of 287496. So the first rule is to put a slash before the last three digits. So you put a slash, okay, so before 496. Now we are going to observe the end digit, or we are going to observe this part. You see that the number, the whole cube number is ending with 6. Now we know that if a number ends with 6, then the cube root value will also end with 6. So that gives us the unit digit of our answer. So now we know that the last digit of our answer should be definitely 6. Okay, so this is our answer right now. We have something on the left, we don't know what we have. On the right, we have 6. Now To find the left hand part of the answer, to find the left hand part, we take the number which lies to the left of slash. So as you had put a slash out here, so now you focus on the next three digit. Now you see that the next three digit 287, okay, 287, you see that this 287 lies between the two perfect cube numbers 216 and 314. Okay, so if this number lies between the cube of 6 and cube of 7, so out of 6 and 7 we chose the, okay, out of 6 and out of 7. So now you see that the given 287 lies between 216, which is the square or which is the cube root. 216 is the cube of 6 and 343 is the cube of 7. So in between these two numbers lies our 287, right? So always remember, well, in these cases we are going to prefer our smaller number, and we take the smaller number and put it on the left hand part of our answer. So out of 6 and 7, 6 is smaller, so we put 6 as the left hand part of our answer. Therefore 66 is the cube root because we had already obtained 6 previously, right? Therefore 66 is the cube root of 287496. Find the cube root of 681472. Now you put a slash first of all. Now you see that the number ends with 2. If the number ends with 2, then if the cube number ends with 2, the cube root number will end with 8. So 8 is the units digit of your answer. Now after that we focus on the next three digits, 681. 681 lies between, 681 would definitely lie between the cube of 8 and 9. So out of 8 and 9 we choose the smaller number, which is 8. Therefore our final answer is 88. We got 88 as the final answer. So 88 is the cube root of 681472. Similarly, to find the cube root of 2197, you put a slash before 197. You see that the cube number given to you ends with 7. Therefore, your cube root will end with 3, right? Because the cube number ends with 7, the cube root number will end with 3. You know it. After that, you focus on 2, okay? Because 2 is just left behind the slash. So you see that 2 lies between 1 and 8. 1 is the cube of 1 itself and 8 is the cube of 2. So out of 1 and 2, you choose 1. Therefore, your answer is 13. So 13 is the cube root of 2197. One more example. To find the cube root of 1157625, firstly you put a slash before the last three digits. After that, you see that the units digit end with 5, right? You see the units digit, or you see that the cube number ends with 5. Therefore, your cube root also ends with 5. Okay. Now we focus on this number. So you have 1157 before the slash. Now you see that 1157, it lies between the cube of 10 and 11. Okay. You see 1157, it actually lies between cube of 10 and 11. So out of 10 and 11, we choose 10 as our smaller number, or 10 is a smaller number, so that is our preferred number. So 10, we have it out here and we put it here on the left. The answer is 105. So this is how cube roots are obtained in just few seconds using the techniques that we've just discussed out here. So here is an exercise which you can solve, and you can also check your answers. I'm sure you're comfortable enough with this technique, and you have to practice often so that it is very much handy to you every time. Okay. So here is a fun fact. Abacus is considered as the origin of the calculator. We didn't know that. I didn't know that, right? So abacus is actually considered to be the origin of the calculator. So that's it for today's class. I'll see you in the next class with a new lesson.